Okay, hello and welcome to our next lesson looking at energy at key stage 4. So we finished off our last lesson where we were looking at reducing heat loss, having a recap of our energy transfer diagrams and our Sankey diagrams, and looking at energy efficiency. Now what we're doing today is we're starting the first of 3 lessons looking at how electricity is generated. Now we're starting off here looking at how it's generated using fossil fuels and looking at nuclear power as well. The following lessons will be about wind and water. The final one will be about geothermal and solar, with our very last lecture looking at how we use electricity and the costs that are involved. So let's start off looking at generating electricity. Exactly how is electricity generated? Now this is just in terms of fossil fuels and in terms of nuclear as well. What we're going to do very first off though is this is a general idea of how a fossil fuel run power plant works. So you may remember this diagram from our look at key stage 3. It was a brief introduction, so what we'll have to do is just have a quick recap of the ins and outs of how it works. So what we've got down here is our heat source. Now this is where our fossil fuels are being burnt. So remember, fossil fuels hold chemical potential energy, and what we're doing is we're actually releasing that chemical potential energy, and this time it's going to be in light energy, but more importantly it's going to be as thermal energy. Now that thermal energy is being transferred into our body of water here. Now this will be through thermal radiation, but more importantly there'll be convection currents occurring within this water. So when the water starts to boil, so it reaches its boiling point, it turns into steam, into a water vapour. Now this, as again, remembering our convection currents, as it's turned into a vapour, into a gas, it's getting hot, so it's rising up. So it's rising up in our system here, and what we have up here at point number 2 here, is our turbine. So what's actually happening is, as our convection current is working around in here, our heat vapour's travelled up and it's travelling through this turbine. Now the force at which it's travelling through this turbine is being turned into a kinetic energy. This kinetic energy is what's spinning our turbine. Now as that turbine spins, it's directly connected to our generator. Now this is where the electricity is actually created. This here is actually what's called an electromagnet. And as it spins, it creates the electricity in the wire, and this is actually the electricity comes out into our transformer. Now, as I said before, I made a stupid joke about it not being a transformer robot, but it actually being something where, because the energy or the electricity that's actually being produced here would be too high to go directly into our house, so you know, your TV would blow up, your PlayStation, your Xbox, everything would be gone, there'd be no more FIFA left for anybody. It has to be stepped down, it has to be put down to a level at which it can be put into your household, and we can do and use all of those wonderful gadgets and everything that we do have in all of our homes. So this is the basic concept of how electricity is generated. This is predominantly how it's obviously done using fossil fuels. Nuclear power plants are slightly different, but also have a lot of similarities, but we'll get to nuclear power. So as I said, we're focusing on fossil fuels at the moment. So this is our energy transfer diagram. So what we have here is at the very top we have our coal, which is, as it says, our store of chemical energy. The energy is transferred as heat or thermal energy to our water and steam, which is our store of heat energy. As that steam, water is produced, as that water is heated, into steam, the steam energy is transferred as movement into our turbine. So this is giving our kinetic energy. So as it travels through our turbine, again the turbine itself is energy transferred as movement, or again our kinetic energy. And this is linked directly to the generator, and therefore the generator is then transferring that kinetic energy into electrical energy. Okay, so we'll go really quick, we'll just go back through that. So coal, chemical energy, transferred into thermal energy. Our thermal energy is transferred to our water, so our water then becomes steam. Our steam is then transferred into a movement, or into kinetic energy. That kinetic energy is pumped into the turbine moves, which again is kinetic energy. So transferred to another kinetic energy, transferred to our generator, which again through kinetic energy is then transferred into electrical energy. Okay, so what are the advantages and the disadvantages of using fossil fuels? So fossil fuels at the moment are still the most widely spread source of producing electricity. There's very large amounts of electricity still generated because they're put in places where it's fairly cheap to transport the coal or the gas or the oil that's actually being used to create it. Also, gas-fired power stations are very, very efficient. They're very good at producing the electricity. So what you find is that the power plants are actually built in places where there's actually sources of these fossil fuels anyway. If not, then they're built near harbours where the fossil fuels can be shipped in, or gas pipelines where it can be directly put to it. So those are the advantages. What's the disadvantages? The main disadvantages of fossil fuels is that concept of pollution. So the main pollution, that is the biggest worry, is carbon dioxide. Now this is directly associated with greenhouse gases and the warming of the earth. The way that the carbon dioxide reacts in our atmosphere is causing layers of the atmosphere to obviously keep, not necessarily actually stop light waves coming through or thermal radiation coming through, but it's actually causing them, as they rebound off the earth, to rebound back onto earth. So it's actually slowly warming our planet up. Another bad side, especially with coal and oil, is the production of a chemical called sulfur dioxide. Now this is directly linked to something which is particularly bad called acid rain. So what is actually happening is that the sulfur dioxide is going up into the atmosphere and into the clouds and mixing with the water in the clouds, and as rain falls and comes back down, as it condenses, it's coming down as acidic, more acidic than water should be, or the water that we would normally get. And as that goes into the soil, it makes the soil acidic, which makes it much harder for us to grow crops, for trees to grow, and in certain circumstances will actually start killing plants that are there. What's the other downside? There's mining coal can be very difficult and also at times really quite dangerous. Unfortunately, you only have to look more recently into South America, where we had problems in Chile with miners, as well as miners in New Zealand and also miners in China as well. In certain times it can be very, very dangerous. And aside from this, certain other types of mining, ones where they're not actually digging right down, but ones where are actually called strip mining, whereas the whole of the landscape is actually cut away. So obviously that has itself massive, massive environmental problems and issues that go with it. Okay, so that was our look. Oh yeah, our big final in big red letters, because I knew I'd forget about it. It's a non-renewable energy source. So once we use it, although it is replaced over millions and millions and millions of years, that's the problem. It's millions and millions of years to replace it. So once we've used it, it's effectively gone. Okay, so we're going to look now at nuclear power. Now, up until now, the only things I've shown you for nuclear power has been the power station from The Simpsons. Now, what we've got here, although it looks quite different, it works predominantly the same as the fossil fuels. What we've got here, what we've got in this section here, is our turbine, is our hot steam coming through here, running through our turbine and getting to a generator and producing our electricity. So this part is exactly the same as what we had with fossil fuels. The interesting part for radiation is what happens over here. So in here we have our radioactive material. Now the most common ones are uranium and plutonium, which are used. Now what actually happens here is the interaction of these radioactive materials causes massive amounts of heat to be generated. So what's happening is there is a cycle of water which is moving around where these radioactive materials are. And as this heats up, it heats up a separate tank of water. So this thermal energy is transferred into the water, which again transfers it into steam. The steam from kinetic energy moves up through and through our turbine, spins our turbine, which spins our generator, which creates our electricity. Now all of this section over here is a cooling mechanism to not only keep the turbine itself cool, but actually to keep feeding cold water into this tank to create the steam. Now this, because the heat produced from this radioactive materials is so intense, there needs to be constant flow of cold water to make sure that it's under control. So again, essentially it's exactly the same as fossil fuels in terms of a turbine spinning from steam, but just exactly how we're creating that steam is slightly different because it's from nuclear materials. So what's the advantages of our nuclear power? So what we need to do is, it's a clean energy source because it does not produce carbon dioxide. Also, it doesn't produce sulfur dioxide. An advantage is the fact that once it's actually built, there's relatively low running costs, and it's actually very, very efficient. The disadvantages though, although it sounds on the surface that this is a good alternative to fossil fuels, the disadvantages are quite large. Nuclear power generates radiation, which can be very, very harmful to people and animals and plants. Also, the waste products that are created from this will stay radioactive for thousands of years, so they need to make sure that it's disposed of properly, which means that any crisis or any problem of which there is spillage of environmental waste, of radioactive waste, will always be really, really bad for both humans and environmentally for animals and plants. And once again, as we prematurely had our big red sign, again, it's non-renewable. Although there are, good sources of radioactive materials, their replacement, again, is very, very long time for them to be replaced. So technically, they are a non-renewable source of energy. So that was our look at electricity generation from fossil fuels and nuclear. So just quickly as an overview, neither of these sources are without disadvantages. Neither of them are renewable sources either. And at this particular point, fossil fuels still remain the most abundantly used for production of electricity. With the consequences of pollution, obviously, and the fact that fossil fuels are on the decline in terms of being found for new sources, there do need to be alternatives found. So in our next lesson we will start looking at some alternatives, although we've had a brief look at one alternative, which is nuclear. Our next lesson, as I said, we'll be looking at electricity generation from wind and water. Okay, thank you very much.